Today we're going to talk about numbers and expressions. A numerical expression contains numbers and operations such as addition, subtraction, multiplication, and division. When you evaluate an expression, you find its numerical value. To avoid confusion, mathematicians have agreed upon the following order of operations. And you'll remember this from elementary school. The order of operations are parentheses, exponents, multiplication, division, addition, subtraction. Okay, it's crucial that you know this order and to remember that multiplication and division and addition and subtraction go together. So it's whichever comes first when you're reading a mathematical numerical expression going left to right. You multiply or divide whichever comes first left to right. Then you add or subtract whichever comes first left to right. For example, if you were asked to find the value of the following expressions, example 1 is 18 divided by 3 multiplied by 2. Okay, so going left to right, division is first, but in PEMDAS, and multiplication and division go together. So you're actually, even though the M is before the D, you're actually going to divide first because it comes first going left to right. Okay, but if there was something in parentheses, you would do that first. If there was an exponent, you would evaluate that first. Okay, remember what exponents are? They're a number to a certain power. So 3 to the second power, in that 2 is the exponent. Okay. So 18 divided by 3 times 2. We're going to divide first. 18 divided by 3. We're going to bring that answer down. 18 divided by 3 is 6. I'm going to bring the rest of the expression down. 6 multiplied by 2. Okay, the product of 6 multiplied by 2 equals 12. Okay, so we're using the order of operations and evaluating an expression. Okay, you only solve an equation when there's an equal sign. When there's no equal sign and it's going to look like a string of numbers, that's an expression. Okay. Give you another example. 6 multiplied by the sum of 2 and 9 minus 3 multiplied by 8. Okay, so in this expression that we're going to evaluate, we're going to look at order of operations. The P is first. So the first thing we do is inside the parentheses. 2 plus 9 is 11. And that's called the sum, because when you're adding numbers, the answer to an addition problem is called the sum. Okay, and so I'm going to bring down the parentheses, bring down the 6, bring down the minus 3, and multiplied by 8. So we're bringing the rest of it down, and now 6 times 11 is 66. Okay, whenever there's parentheses and a number right on the outside, that indicates multiplication. Okay, but there have to be parentheses there. So 66, and I'm going to bring the rest down, minus 3 multiplied by 8. Okay, so now we have a subtraction and a multiplication left. So according to PEMDAS, multiplication and division come before adding and subtracting. So we're going to multiply first. 3 times 8. 3 times 8 is 24. We're going to bring down the 66 and the subtraction sign, which can also be called a minus sign. Okay, this is also the difference between 66 and 24. That's another way to say it. 66 minus 24 is 42. Is in math is also equals. Equals means is. So equals 42. That's the answer. So we've evaluated this expression using the rules of PEMDAS, which is also called order of operations. They go hand in hand. They're the same thing. And another example would be 53 plus 15, and you could also say the sum of 53 and 15, divided by 17 minus 13. Okay, you could also say the difference of 17 and 13. So 53 plus 15 is 68. That equals 68. And so we're just going to bring that over. Okay, this is a fraction. Any fraction can be a division problem. And so we're going to end up dividing this fraction because I can tell that the numerator is bigger than the denominator. Okay? If the numerator is bigger than the denominator, it's called an improper fraction, and you have to divide. 17 minus 13 is 4. Okay, so now we have 68 divided by 4 equals, let's see, this is a good example for a division problem. Okay, because sometimes you can't do it in your head. 68 divided by 4. Okay, a couple digits here. So the numerator will always be divided by the denominator. The denominator goes on the outside, and then the numerator goes on the inside. Okay, so 4 goes into 6 one time. So the steps of division are divide, multiply, subtract, and then bring down. So we're going to divide. We just did that. 4 into 6 goes one time. Then we're going to multiply. 4 times 1 is 4. Okay, next step is subtract. 6 minus 4 is 2. Last step, bring down the 8. Okay, and then you start at the top again, divide. So now 4 into 28, or 28 divided by 4. Okay, 28 divided by 4 is 7. Okay, that one was a little bit hard to do in your head. 17 is kind of an odd number, and so it helps to set up a division problem. And the answer is 17. Okay, the other thing you need to know how to do is translate verbal phrases into numerical expressions. So a verbal phrase is a sentence. A numerical expression is numbers. So you've learned to translate numerical expressions into verbal phrases. It's often necessary to translate a verbal phrase into a numerical expression. So for example, the directions would be something like this. Write a numerical expression for the verbal phrase. And one of the problems could be the product of 8 and 7. So that'll be written out as a sentence, the product of 8 and 7. And you have to write it as a numerical expression. So the verbal phrase will look like this. The product of 8 and 7. Okay, product and multiplication, in math means multiplication. Okay, so that means multiplication is going to be your operation. So the product of 8 and 7 is going to look like this. 8 times 7. That's how you'd write it. If you're not asked to evaluate the expression, you just leave it like this. 8 times 7. That would be your answer. If you were asked to also evaluate the expression, then you would actually answer it. 8 times 7 equals 54. Okay? Another example of a numerical phrase that you need to change into, a verbal phrase that you need to change into a numerical expression is the difference of 9 and 3. So it'll be written like this. The difference of 9 and 3. Okay, and I would write that as a subtraction problem because the difference between two numbers is subtraction. So that's going to be 9 minus 3. Okay, 9 minus 3 equals 6. And you only need to add the equals 6 if you're asked to evaluate the expression. Okay? Sometimes you will be, and sometimes you will just be asked to translate the verbal phrase into a numerical expression. Okay, so you want to read the directions carefully. Okay, the sum of 10 and 3 is another example. the sum of 10 and 3. Okay, that's going to be the number 10 plus 3. Okay, adding and sum are the same thing. And the last type that you'll see is the quotient of two numbers. So if you have something that says find the quotient of, say, 14 and 7, that means 14 divided by 7. Quotient means division. In the numerical expression, whichever number comes first goes first. In the verbal phrase, whichever comes first goes first in the numerical expression. So the verbal phrase was the quotient of 14 and 7. Okay, and this is how you translate it into a numerical expression. If you were asked to evaluate it also, you would just answer it. 14 divided by 7 equals 2. You'd evaluate it. Okay, the next example is a word problem, and where you have to translate a word problem, something from real life, into a mathematical expression. So, for example, a cell phone company charges $20 per month and $10 for each call made or received. Write and evaluate an expression to find the cost for 44 calls during 1 month. Okay, so we know that there's a flat fee of $20 a month, right? $20 every month. Okay? That's a given. Then, you know it's 10 cents for every call. Okay, if there are 44 calls made and received, you're going to multiply that by 10 cents. 44 times 0.10. Okay, and this is actually a plus, because $20 is the flat fee. And you're adding that to the product of 44 times 10 cents. Okay, 0.10 represents 10 cents. Think about it like you were writing money. If you were writing $5.10, okay, the 10 cents is after the decimal, because it's 1/10 of a dollar. Okay, so now you're going to use order of operations and evaluate this expression. So you're taking a word problem, turning it into a numerical expression, and then evaluating it to find the answer. Okay, because of PEMDAS, multiplication is going to come before the addition. So we're going to multiply first. And when you're multiplying by a decimal, there's a rule for that. You multiply like normal, and then you add back in however many decimal points you took out. So you're going to do a regular double-digit multiplication problem, then you're going to add the decimals back in. So you don't even need to pay attention to the decimals until after you multiply. Okay, so it's going to be a 0, and then 4, and a 4. So the answer is 440. Now, we took out 2 decimal places, 1, 2. So we're going to go to the end of this answer, and we're going to add back in 2 decimal places. Oops, I'm sorry, I forgot a 0. So I did that shortcut. Normally, this first line would be 0, and then we'd go over another 0. So actually, oh no, that was right. That was right. Okay, so we'd go over 1, 2. It's going to be $4.40 more for those 44 calls. 44 times 10 cents. So we took out, we ignored 2 decimal places, and then we added them back in. From the end of the number, you go back 2. Okay, so that's $4.40. Now, the rest of this numerical expression is $20 plus. So it's $20 plus, I'm going to bring that down, $20 plus $4.40. Okay, you can probably do that in your head. $20 plus $4.40 is $24.44. And that's how much it would cost per month. Okay? So in your book, we're going to work on problems 2 through 28 on page 34. So it's page 34, 2 through 28, and we'll do the even.